Hello, geometry students. Unit 11, homework 4 notes. We are doing the area of regular polygons. So the distance, first of all, let's go over the parts of a regular polygon. So the distance from the center of a polygon to any side is called the apothem. And because I pronounced this wrong for so long, here we go.
Apothem.
So apothem is the correct way to pronounce it. And that is this distance right here from the center of the regular polygon, in this case the regular hexagon, to straight to its side. That's the apothem. Okay. Next is the radius. Radius is what you think. It's the distance from the center to the vertex, so the distance from the center to one vertex, just like it is in a circle. So there's the radius right there. So I'll label this A, and I'll label this R. Okay, and then the area formula, which is on your guys' little formula sheet that has all the formulas on it. I believe, oh, I lied. It's not on here. But the formula is 1/2 apothem times the perimeter. Okay, so we're going to use it here in some examples. Let's first do a triangle. I know you're used to doing a triangle 1/2 base times height, but this time let's use the formula for a regular polygon, 1/2 apothem times the perimeter. So 1/2 the apothem is 7, and the perimeter is going to be 24.2 times 3, so I'm just going to write 24.2 times 3 because there's 3 sides. Pretty straightforward, and you get 254.1, and once again we're dealing with area, so we want square units, square feet, and that's rounded to the nearest tenth. Alright, so these problems are pretty easy because they give you the apothem and they give you basically one side length to find the perimeter, but they can be a little more challenging because sometimes you're given say just the apothem and nothing else, and you need to find some other information first to use the formula. So these steps here are helpful. You're going to create a right triangle between the apothem and the radius, just like I've done here, and you're going to find the measure of the interior angle, which is this angle right here, that central angle. Alright, usually we're going to do that different ways. We can take 360 divided by the number of sides, or we can try to use a special right triangle. So this angle right here is going to be 30 degrees, and if you wonder how I know that, well, if you draw in all these, if you extend all the sides, a line to all the sides, I'm going to do a dotted line here, then there's 6 of these big triangles that make up this shape. So divided by 6, you get 60 for this whole angle here, and then obviously half of that is what we're looking for because we only want half of that triangle made by the sides and the radius. So that's going to be 30. In which case we have a special right triangle, a 30, 60, 90 triangle there. I'm going to draw it a little bit bigger so you can actually see it because it's getting a little small. So we have a 30, 60, 90, and I know that this side, the apothem, is 5. Okay, our special right triangle values, if this is x, this is twice that side, and this side is x squared of 3. So we're going to use that information for our special right triangles to find what I'm calling x here, which is the small side. Alright, so x is 5 divided by the square root of 3. If I divide both sides of this equation by the square root of 3, I have x is 5 divided by the square root of 3, which is approximately 2.89, and I'm going to use that now in my formula. So my formula is 1/2 apothem times the perimeter. The apothem they gave us was 5. Now I can find the perimeter with this value, which is half of my side length. So if half of my side length is 2.89, I'm going to times that by 2 to get the whole side length. So 2.89 is half the side length. Multiply it by 2, I get the full side length. Multiply by 6, and I get the entire perimeter. So I'm going to take that 2.89 and basically multiply it by 10, because there's 10 of those little parts around the hexagon to get the whole perimeter. Okay, and that gives me my answer of total 86.7, and we want square centimeters for our unit. So that one was trickier because we actually had to find more information before we could find the area. And I'm sorry, I made a small mistake. This is supposed to be a 12 right here. There's if you multiply it by 2 and then times 6, that's 12, not 10. So there's 12 of these little parts around of this little 2.89. And that gives you the correct answer of 86.7. Okay, so let's try number 6. Once again, area is 1/2 apothem times perimeter, in which case we know the apothem is this huge number, 6 kilometers. And we want to find the perimeter though. So once again, we're going to do the same thing. We're going to break this up into a triangle, and we're going to try to find this little distance right here. This little distance I'm going to call x. Alright, first of all I need to find this angle up here. So if you imagine, once again, drawing in all these bigger triangles made by the sides, made by drawing a radius to each side, each vertice, there's 8 of them because this is an octagon. So 360 divided by 8 gives you, each of these angles would be 45 degrees. And we need half of that because we just want this little angle right here. So this little angle, if you can see, is going to be 22.5. Okay, so I'm going to redraw that triangle just so you can see it, hopefully a little bit bigger. This is what I'm calling x. This is 6, and this is 22.5. Now we're going to have to use SOHCAHTOA, so we're going to do tangent, opposite over hypotenuse. So I'm going to do tangent of 22.5 equals opposite over adjacent. Hope I said adjacent. And you're going to multiply both sides by 6. That gives you this little distance x, which about 2.49. Okay, so that's just this little side, but once again we need to double it and then multiply it by 8. So we need to multiply it by 16 total. 2.49 times 2 times 8 is times 16. Alright, that gives us the whole perimeter around. Alright, and then if you multiply that by 6 and by 1/2, you'll get your total area, which comes out to be 119.52. And that's kilometers squared, or square kilometers, for our area. Let's try number 7 now. Once again, draw your triangle in formed by the apothem and your radius. Alright, and then you are going to try to find your angle right here. So once again, if you draw the big triangles formed by the side and divide it by 5, you get 72 degrees. So half of that would be 36. So this angle right here is 36 degrees inside of there, if you can see that. Alright, so I'm going to use that information to try to find everything I need. So I have area equals 1/2 apothem times perimeter. The apothem I don't have, so I need to find. Half of 8 is 4, so I'm going to use this right triangle to find the apothem. Alright, so I'm going to do opposite over adjacent. I'm going to do tangent of 36 equals opposite over adjacent. You guys know how to solve this. You're going to end up switching and make this 4 divided by the tangent of 36, which gives you about 5.51 inches for the apothem. Alright, and then I need the perimeter, so the perimeter is just 8 times 5. Alright, and that gives you your answer of 110.2, and that's square inches. Next one for number 10, same thing, draw in your triangle formed by the apothem and the radius of your figure. So this is A, this is our radius R. Alright, now we're going to find that angle. So once again, you know, however you want to look at this, I'll do the exterior angles this time. So you know the exterior angles have to add to 360. So each one of these is 120. I'm sorry, each of these angles, interior angles, not exterior, is 60 because it's an equilateral triangle. So 60, and then half that's 30. So you know this is a 30, 60, 90 triangle. So let me draw that triangle a little bit bigger down here real quick. Here's your 60, 30, 90 triangle, where this is A, and this is 4.5 because it's half of the 9 that's given right here. Okay, so now we're going to do our special right triangle values. If our small leg is A, the hypotenuse is 2A, twice that, and our longer leg is A times the square root of 3. So basically we know that the A times the square root of 3, or the apothem times the square root of 3, equals 4.5. Alright, right from this down here, our special right triangle values. We're going to divide both sides by the square root of 3, and that gives us our A of about 2.6. And that's centimeters. So now we're going to do our area formula. It's 1/2 apethum times perimeter. So it's 1/2 2.6 times, and then the perimeter is just 3 times 9. All right, and that gives us our final answer for the area of this, which is 35.1 centimeters. Next, let's try 11. Once again, draw in your apethum. It doesn't matter, I could draw it in right here, but I'll draw it here. In which case, I'm going to remind myself that the hypotenuse of that is 3. Okay, so this is a square. We know that this is a 90-degree angle in the corner of the square, so this is a 45. So we've got a 45, 45, 90 triangle, which is once again one of our special right triangles. So let me try to draw a 45, 45, 90 triangle. 45, 45, 90, in which case the hypotenuse is 3. Our special right triangle values are x, x, and then x square root of 2 for the hypotenuse for our special right triangle. So we're going to use this relationship for the hypotenuse to find x, or the what we're calling the apethum. So divide both sides by the square root of 2. Our x is 3 divided by the square root of 2. So that is our apethum. 3 divided by the square root of 2. So our area formula, area is 1/2 apethum times perimeter. 1/2 3 divided by the square root of 2 times, and then the perimeter for this is going to be the same value. This 3 divided by the square root of 2. And we're going to multiply that by 2 to get the full side length, and then we're going to multiply it by 4. So we're going to take this 3 over the square root of 2, multiply it by 2, and then by 4 to get the whole perimeter. So multiply it by 2 to get the side length, and by 4 to get the whole perimeter. Okay, so we're going to carry out this multiplication. I see this 2 cancels with this 2. In the top I have 3 times 3, which is 9, times 4 is 36, over 2, which is 18. And the units on that would be square miles. So then the last problem is problem 14. We're going to, once again, area is 1/2 apethum times perimeter. Once again, we need to find it. So we're going to draw our triangle in right here, try to find our apethum, and also, you know, this little piece to find our perimeter. But before we do that, to find the angle, this time I'll do it differently. I'll find an interior angle here by using our formula n minus 2 times 180, and then if you divide that by the number of sides. So this gives the sum of the interior angles of any polygon, and if we divide it by the number of sides, which is 5, and obviously plug in 5 for our number of sides, that will give us one of these interior angles, which is 108. And then if you take 108 and divide it by 2, you'll get this little angle right here. So 108 divided by 2 is 54. So this angle is 54 degrees. And I'm going to use that angle now on this problem. It doesn't matter. You can do it the way we did it before, where you break this into 3 triangles, or I'm sorry, 5 different triangles, and take 360 divided by 5 to find each one of these, and then cut that in half. In which case, this would be 36 right there, if you did it that way. And that way works fine. Obviously, these are complementary angles in this triangle right here that we formed. So either way, I'll use this 54 for now. So I want to find my apethum, so I'm going to do opposite over hypotenuse. So I'm going to do the sine of 54 degrees equals opposite apethum over the 19 they gave us for the radius. All right, I'm going to multiply both sides by 19. And now I have the apethum, which is approximately 15.37. And then my perimeter, I need to find this other piece here. So I'm going to do adjacent, and I'm going to use the hypotenuse. So I'm going to do cosine. So if I do cosine of 54 equals my adjacent, I'll call that x for now. Adjacent over hypotenuse, which is 19. Multiply both sides by 19. And you get about 11.17. Now that's just this little distance right here. So I do need to multiply that by 2 and then by 5 to get the total perimeter. So I'm going to take that 11.17, multiply it by 2 and then by 5 or by 10, and that gives you the entire perimeter of 117. So this whole value is 111.7. But if you multiply it all out, you get the total area 8 58.41 square meters. All right, I hope this video helps, and once again, let us know if you have any questions.